Hi Math 213. In this video we're going to be continuing our work in section 12.1 where we're working with congruence and constructions. We're going to begin this video by talking about constructing congruent angles. We'll be doing constructions using a compass and a straight edge, and so what that means is that we're going to be copying an angle if it's given to us already drawn out like this, as it is in this example here. We won't be able to construct congruent angles if we're just given the degree measure of an angle. We won't be able to do this strictly with a compass and a straight edge because it's not possible to do that construction starting with an angle measurement and only using a compass and a straight edge. If you are actually given an angle measurement, so for example 45 degrees or 47 degrees or something like that, it's not possible to do that kind of construction with a compass and a straight edge. You would have to make use of a protractor or some kind of geometry drawing utility or a computer program or something like that. So in this case what we're doing is just copying an angle that's given to us already, and we're just going to copy it directly from its image. So this is the construction steps that we're going to be following, but let's watch one of the videos provided by our textbook to copy an angle.
For this construction, we will be copying an angle. We're going to copy angle B by placing the pointer at B and opening the compass to any width, as long as it doesn't go past the length of the top side of the angle. Draw an arc across both sides to form arc AC. We'll go ahead and label the top point as A and the bottom point of intersection as C. Keeping the compass set at the same width, we'll place the pointer at B prime and draw the same arc that we just did. Label point C prime where the arc intersects line L. Now we'll go back and measure the distance across our arc in our original angle. Placing the pointer at C, open the compass to measure across CA. We'll then move the pointer to C prime and mark a cross arc. We'll label this point A prime so that C prime, A prime is going to equal CA. As a final step, we'll take our straight edge and draw line segment B prime, A prime going through point A. This gives us angle B congruent to angle B prime.
Okay, so we were able to see a construction of a congruent angle in that video, which is really nice to be able to watch those later when you're going to be working out your homework problems. You'll be able to reference these later. That's something really nice you wouldn't have had if we had done a lot of these constructions first time through in class. So let's continue on and see what other kinds of constructions we can make use of here in this section. So one of the first things we're going to talk about is what's called side angle side property, and this really goes something like this. If you have two sides and the included angle of one triangle, if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. So really what this means is that this specific relationship about having side angle side allows you to say two triangles are congruent. So let's just say I have two triangles here, pardon the curved edge there, right? Okay, and I'm going to mark them specifically like this. If I knew this side and this side were congruent, I can see that these two are both right angles, so those angles are congruent. And if I knew that this side was congruent to this side, then I could make use of the side angle side property here to say that this triangle is congruent to this triangle because I have side included angle side congruent to side included angle side. Okay, let's see if we can do an example to show how this works. So we want to use side angle side to show the given pair of triangles are congruent. So notice here that we have in this first example, AB is congruent to ED, AB is congruent to ED, they both have length 4, angle B is congruent to angle D, Angle B is congruent to angle D. They both have a measure of 70 degrees. Notice it doesn't say equal. It also doesn't say measure, right? Because remember, the alternative would be to say measure of angle B equals measure of angle D, right? But since we want to make use of congruency here, it's better to use the congruent notation. We also have BC being congruent to DF, BC congruent to DF because they both equal C. So notice that's side, angle, side, where the angle is included between the two sides, and we have side, angle, side, right? So by side, angle, side, we know that these two triangles are congruent. Triangle ABC is congruent to triangle EDF. In this next one, it looks like we actually have a couple of triangles constructed from a parallelogram by a diagonal. We have AB is congruent to CD, they're both 6, and we have DB is congruent to BD because that's the same side, they share that side. Yes? We also know angle ABD, that's this angle here, is congruent to angle BDC because that's this angle here, since they are alternate interior angles. Yes, remember that this is a parallelogram, so we've got opposite sides being parallel, and BD is the transversal cutting those parallel lines, so that means we have alternate interior angles being equal. So we have by side, let's see if we can label it, side, angle, and then this would be that other side, right? By side angle side, we have congruent triangles. Okay, so we're jumping through the slides a little bit in reverse here, so we actually need to go backwards. One. So now what we'd like to do is do a construction involving this side angle side notion. So if we had a triangle given here, we'd like to construct a congruent triangle using this side angle side construction. So let's, this is the text sort of for it, right? We're going to take a ray and then construct a line segment congruent and then construct an angle, but let's watch a little video to see exactly how this works. Okay, here we go.
To construct a triangle congruent to triangle ABC, we'll use two sides, AB and AC, and the included angle A, formed by these sides. First, a ray with an arbitrary endpoint, A prime, is drawn. Label the endpoint A prime. Now measure the distance across segment AC. Place the point at A and open the compass to C. Transfer this distance, putting the pointer at A prime and constructing C prime. Next, we'll copy angle A. Placing the compass point at A, we'll draw an arc across sides AB and AC. Make this same arc, putting the pointer at A prime. Measure the distance across the original arc. Transfer this distance, putting the pointer at the intersection of A prime, C prime. Draw a ray from point A prime through the intersection of the two arcs. Copy side AB by placing the compass point at A and opening it to the distance of B. Mark that distance along the new ray and label that point B prime. Now connect points B prime and C prime to complete the copying of the triangle using side angle side construction.
That'll be it for this video. We'll continue 12.1 in our next video.